Okay, can you give a brief overview about like who you are, anything you want to share, anything specific since you're anonymous?
Yeah. So I am a PhD new grad, and I am interviewing. I will be interview with Google, and yeah, it will be on-site interview. I think it's likely to be in person. Yeah,
Okay, cool.
and yeah, that's
I wonder if they're doing more in person because of cheating these days. Maybe.
I guess so. Yeah, that's what I heard.
That's cool that they are sending. I feel like it's kind of interesting to go in person. Like, okay. Okay, cool.
Yeah,
Okay, so the first question we're going to have is going to be pretty straightforward. So you're going to have two numbers given to you as strings, and they will be in decimal format. So let's say maybe like this as the first one, and the second one might be like, I don't know. And basically what I want you to return is return the sum of the numbers in decimal, or in string actually. So imagine these numbers are too big to transform to a float, because maybe they're like a million characters or something. I don't know.
Oh,
So how would you do this? So you're given like A, that's like a string, and B, that's a string, and you want to get C. So like in this case, C would be what, like 1, 2, 3 point whatever this thing is, right? 3,
yeah.
5, 7, 32 or something. Okay, so this should be like your answer.
I see. So we should return the numeric value. Okay.
No. So it's too big to fit in an integer, so you need to return a string.
I see. Sure.
So you can't convert them to like decimals and add them together because you can assume they're too big to fit in a decimal.
That makes sense. Sure.
Okay.
Okay. Interesting.
And we're gonna go until 7:35 PST. So just watch your time. I'll let you know when we're 25 minutes in.
Sure. So yeah, let me think about this. This is an interesting question. So I guess, okay, the string, and we want to add them together, and then not in the numerical way, but I guess it would be something like, because the output is also string, and then it might be too large, so we would probably add it like digit by digit. That's something I would imagine. And I guess I would like to ask some clarifying question.
Sure.
Yeah. So is it guaranteed like there's a decimal value, or maybe not? Maybe just an integer.
So to make it a little bit simpler,
Yeah.
it's guaranteed that they're both decimals. So there will never be a case, because it's like kind of annoying to handle all these things. So there will never be a case like this. It will always have a decimal after. There will never be a case like this. So these will never happen, and this one will never happen either. So it's a full, like, there will at least be one value on both sides of the decimal.
Sounds good. And yeah, but sure. Then let's handle this first. So let me think. Then if that's the case, I think it's much safer. The first thing that comes to my mind is like, we could probably use something like split.
Okay.
Like, yeah, we can split, because like as we know right now, the decimal number, there must be value before the dot and value after the dot. So we could probably use something like a dot split with respect to dot.
Okay.
Yeah, and then we can effectively separate the value before the dot and then the value after the dot. Yeah. And then I think I will add them together. Like, so wait a second. Let me think about this. Yeah. So for A, we will have 2 par, and B, we will have 2 par. For example, like I may call it A1 and A2. These are like the thing that after separate. Let me see if I probably something like that. And then B could also be like this. Yeah, and then I would handle the addition digit by digit with A1 and B1, and then A2 and B2.
Okay.
Yeah, and after the summation for each part, then I would connect them together again. Oh yeah. Okay, let me think about this. And we probably need to be aware of when we summing A2 and B2, there might be some carry.
Mhm.
Yeah, and then I would also add it to A1 plus B1 again before we merge them.
Okay, so basically you're saying I'm going to split it, I'm going to add the parts separately, and then if there's a carryover from the decimal part, I'll add it into the numerator part, right?
Yes, that's
And
what
then add it together at the end. Yeah, I think that makes sense. And what would be the time and space for that?
Yeah, let me think about this. So the time and space complexity would depend on the length of A and B.
Mm-hmm.
Yeah, let me think. At least we would go through digit by digit. Wait a second. Yeah, so if this is just like let's say like the length of A is M,
Mm-hmm.
and then the length of B is N, and I think the time and space complexity would be just M plus N. Yeah, because we would do it digit by digit. And then I think the worst case scenario is like, for example, like A is like this, and then B is like something like that. Just like then when we do the A1 plus B1, the time and space complexity would be nearly N. And then A2 plus B2, the time complexity would be nearly M. Yeah. So
Okay.
the time is yeah. That's what I think. Yeah.
Yeah, I think that makes sense to me.
Okay.
Okay. Do you want to code it then?
Yes. I think I'm ready.
Okay.
Sure. Should I write it as a function
Yeah.
or? Okay, that makes sense. And I just assumed that A. Wait a second. Let me double check. Before I write the function, I just want to quickly confirm. I think it maybe is what I think, but like, so the A and B will not be empty string, right?
Yeah.
Because okay,
You will always get at least one number on each side of the decimal.
Mm-hmm.
And I guess you didn't ask, but they're always going to be positive as well.
Oh, sounds good.
Mm-hmm.
Yeah. And sure, okay. And then we'll just define it as maybe I call it add to number.
Sure.
Sure. 8 to number. Okay. And then we have the A and B. These are two input, and then we we know it will be a string. And then the output, I think it's also a string. That's what we want.
Okay.
Yeah, and okay, a string. So the very first thing is, yeah, just like what we say in the beginning, we want to split it into two parts. Split it. One in A2 and B1, B2 is equal to B dot split.
Okay.
Yeah. And let me think about this. We want to handle the A2 plus B2 first. I just want to think about whether I need to worry anything about A1 plus B1. Seems not. Okay. Okay, let's just add A2 plus B2 first. And let me think. Oh, interesting. Okay. Yeah, I'm thinking, for example, like if we look at this example, A2 is 2, 3, 4, 3, 2, and B2 is 1, 2, 3.
Mm-hmm.
Yeah, and then we want to edit 2 with 1 and 3 with 2. So I guess, yeah, and we also need to care about the carry because there might be a carry after adding everything to the integer number. Yeah, so I guess what I can think of is I want to make A2 and B2 the same length so that I can add them easily.
Okay.
Yeah. I'm not sure. Okay. Yeah, this is something I came up to my mind. So let me think about this. Yeah, at this point, we don't care the order of A2 and B2. We just want to add them together, and then we want to know the final result.
Mm-hmm.
Yeah, so if the length of A2 is less than, okay, I guess I can just do this, less than B2. So basically, I'm trying to handle when their length is different.
Mm-hmm.
Yeah. And then what I want to do is, for example, if like A2 is 2, 3, 4, 3, 2, B2 is 1, 2, 3, I want to add 2 more 0.
Mm-hmm.
So yeah, so that I can easily add them digit by digit from the last digit, if that makes sense.
Yeah, makes sense.
Sure. And okay, so if the length of A2 is last, then I will just make it, I think we can just plus equal to number of 0, and then how many of 0 would be the length of B2 minus the length of A2.
All right.
And then, yeah, if later we want to make it more efficient, I can think about it. Yeah, but here I just want to first solve things.
Sure.
Yeah, sure. So yeah, and then if the length of B2 is last, we do the same thing, but then we add 0 to the B2.
Okay.
And yeah, that's what we. So now the length of it are the same. And we want to create, let's just call it C2. And let's see. Oh, yeah, interesting. Let me think about this. C2, do we want it to be? I want something from the last integer. Yeah, for C2, here I wanted to make it an array. And then I would collect the character along the way. And then after we collect all of them, when the during the output, I would just reorganize it into a valid string.
Okay.
If that makes sense. Yeah.
Yeah, makes sense.
Yeah, I feel like it's easier to handle for me. Yeah. But okay, I have the array, and then okay. We want to do it from the last digit, and then we want to keep adding it. And okay, so here I just want to say, wait a second. 2B, A2, B2. Yeah, so let's just start adding A2 and B2. So here, just something to remind me. So A2 now is this. Just use this as example. B2 is 1, 2, 3, 0. Okay, and then for I in range of the length of, now the length of A2 and B2 is the same.
Mm-hmm.
And we started from the last integer, last index, and all the way go to 0. And then what we also want to have is the carry, because when we added the digit, it might have some carry that we need to carry over to the next digit.
Yep.
So the carry initially will be 0. So here is something I want to put here. Okay, just make it. And let's see. So we will start adding. So it will be A2, I, and then when we add it, we convert it into integer plus the integer, B2, I, and then we also plus carry. That will be the value.
Okay.
Yeah. And okay, after adding this, then we would have the value, and this value represents the sum up to this digit, and it might be more than more than 9, for example, like 11 or something. So we want to, before we append it into C2, we want to make sure we take over the carry first. And yeah, so the value, the way we do it is, I think we can just divide it by 10. Yeah, that would be the carry. That would be a new carry.
All right.
For example, yeah, 11 and then we integer division with 10, it would be 1. So that means like this 1 must go to the next digit.
Yep, makes sense.
Sure. And then we would append the value percent to 10, which is like, for example, what I say is 11, then 11% 10 is 1. And then this 1 represents the value that we should append into the C2. And of course, sorry?
No, yeah, makes sense.
Okay, sure. Yeah, of course, by appending things using this way, the C2 is in the reverse order. So we want to reverse it after we do all the operation. Yeah, okay. And after all of this, I think we would successfully adding all of this. And then we would have the carry that need to go to A1 plus B1. And this C2, I can just reverse it so that it will be something that I want. Oh, yeah, let me think. I think it may be easier when I append it into the C2, I just append the string. I just convert it into a string.
All right.
Yeah, sure. Okay, so now in terms of this case, let me slightly modify it so that I have carry. And so in terms of this case, then I think the C2 should be, up to now, should be 2, 3, 7, 5, 1. And then the carry go to the integer should be 1.
Mm-hmm.
Yeah. And okay, then we would do it again, but now with A1 and B1. So I think, let me think. We'll almost get the similar result. So here I would just kind of copy and paste, but now it's with A1 and then B1, and I would have a C1. Now carry, we already have that from the A2 plus B2. And then here, instead of A2, we have A1. Sorry, I think I will still, wait a second. Am I doing the same correct way? Oh, interesting. So A1 plus B1. Sorry, before adding all of these, let me think about how to add A1 and B1. A1 and B1.
We're at 25 minutes left, by the way.
Oh, okay. So should I stop here or?
You can keep going, or we can go to the second problem. Up to you. I think you're almost done. So.
Oh, sure. But like, I could do it faster. But let me think. A1, B1. Maybe 5 more minutes.
Sure.
Sure. Okay. Yeah, I guess for A1 and B1 is like, I want to create something. think. Let me think about it. Yeah, I just need to know how to handle when there's no digit. Okay. I guess I would stop here. But
Okay.
I can see my bottleneck is like I don't have an efficient way to, like, if you give me two string of number, then I don't have an efficient way to adding them. I definitely done similar problem before, but like I forgot how to efficiently like
Cool.
adding two number. Yeah,
Okay, so
sure,
let's just move on to the second one.
sure.
Okay. So in the second one, you are given let me just... Okay, so you're given a string of parentheses. Okay. So
Yeah.
let's just comment out all of this.
Sure.
Okay. Comment out this. All right, good. Okay. So you're given a string of parentheses, for example, like this. And you are given another string called locked. And so this is zeros and ones. So locked being 1 means you can't modify this. Locked 0 means you can. And what I want you to say is, can we make this valid, modifying whatever we want, whatever's unlocked, basically. Is there like a valid way to make this thing work? Does that make sense? So let me just continue with the example. So basically, like, let me make this a little bit easier to read. So if this is this, like, let me spread it out. So basically, the ones you are allowed to modify is this one, and these two. Okay. So because you are allowed to modify them, I can just swap this to this, and then okay, I don't know what happened there. Okay, and now I can also swap this to this, for example, and now it would be valid, right? So
Yeah.
but there are some obvious examples where you can't modify it, or it wouldn't be valid. For example, if everything was locked and it was invalid and things like that. So basically, it's like, given this string of parentheses and this lock thing, can you modify the parentheses to be valid? And I just want you to return Boolean yes or no.
I see. Yeah.
Cool.
Sounds good. Sounds good. Yeah. So some clarify question. So there's only this kind of parentheses, right?
Yeah, it's only open and close parentheses, and yeah.
Sure. And I guess the length will always match for
Yes.
S a lot. Okay, sure. Okay. And then should I worry about empty string like S?
Well, so empty, what do you think empty would give you?
Be just true.
Yeah.
It
So
sounds
like, so no parentheses is valid parentheses. So yeah.
sure. Okay. Think about this. I just have some initial thought about this.
Uh-huh.
Yeah, I'm trying to combine these two, but wow, it's this. So, while I have experiences, is like given a string, I know how to use stack
Okay.
to identify whether that's a valid parenthesis or not.
Mm-hmm.
Yeah, basically, like I would have a stack to include all the open parentheses and then track if there's any closed parentheses when there's nothing in the stack. Yeah, and now we also have a lock information. I feel like this is maybe similar to what backtracking can do. Let me think. May I ask what is the length? What is the order of the length of the S?
Okay, I'll tell you it's too long for backtracking.
Sure. Okay. Yeah, then okay. No, not backtracking. Yeah, because backtracking only work when the order is very small.
Mm-hmm.
Okay, cool. Mm. For example, yeah, I would just say what I think, and I would try to see if there's anything that I can use.
Mm-hmm.
Sure. So if I do it normally, then these two close parentheses, we will never find an open parenthesis to match it.
Mm-hmm.
Yeah, and then now here we have open parentheses. And then, okay, so we can match with any of those close parentheses, but then we will have two close parentheses. And that's not able to match.
Mm-hmm.
Yeah, so okay, so it seems like as long as wait a second. So any of the two, yeah, any of the two close parentheses. Wow, this open parenthesis could also match with any of the close parentheses. Okay. I'm trying to think if there's anything that I can make it simplify.
Mm-hmm.
Yeah, not sure how to do it.
So I guess to give you like a small hint, so in your like let's say everything was locked, right? You would have opens and then you would match them with closed, and whenever you have a close, you'd like pop off an open or something, right?
Yeah.
So now you have things that are locked and unlocked. So unlocked can be anything, right? So if you have a closed parenthesis and you have an open parenthesis before it or an unlocked parenthesis, which one's better to match it with?
Sorry, just to clarify, when you say unlock, what do you mean by unlock?
So unlocked, like locked is 0, you
Oh,
can make it open or closed, right?
sure.
So if I have an example like this, where this is stuck, right? So this is like locked.
Mhm.
Then I have another one that's like unlocked. Then I have a closed that's locked. Okay.
Oh,
So
okay.
this locked, I have to match with an earlier one that's open, right?
Yeah.
And I can either match it with an open or an unlocked.
Yeah.
Which one's better to match with?
The lock one,
And why is that?
because the unlock one I can use it later.
Right.
Possibly use it later. Yeah.
Right. So can you think of something like that? Maybe separate them out into like two different types of things. Like the normal one, if it was all locked, you would just have opens and then you would like pop off. So can you separate them out maybe, and then like you said, use the open first, and then figure out how like what the end has to look like for it to be valid.
I see. Yeah, let me think about this one. So I guess what you're saying, yeah, we should focus on the closed one, the lock one first. And then
Yeah, like imagine if everything was locked, you would try to match everything with unlocked, right? Or you would match opens with closed, and then what's your like final thing you have to check for?
if everything is locked,
If everything
then
was
it would
locked, you would match
Mhm.
open with closed, and then what's the final thing you have to check for to make sure that it's valid?
like I would check the number of close parentheses, unmatched close parentheses, and unmatched open parentheses.
Right. And then basically if you have unmatched, so I guess if you have like imagine everything was locked, right? Like if you ever have a case like this where you have too many closed, like every
Mhm.
closed needs an open before, right? Or it's just not valid. And then the other thing is like you have something like this, you need to also make sure that like all the open are matched at the very end, right? So it's like
Yeah,
every closed while you're iterating has an open before, and you have no more opens on the stack. That would be like completely locked, right?
yeah.
So with this one, now you have two different things where you have anything and the same thing. So how do you modify that problem to handle this and do kind of similar stuff? And like you said, if you have a closed, you'd rather match it with a open than a unlocked because unlocked is more flexible.
Hmm. That makes sense. How much time do I still have?
Say about 12 minutes.
12. Okay, sure.
Yeah, and if you don't like code the whole thing, that's fine. We can just have a very solid approach if you want to do that. So let's just get whatever we can done.
Sure. Yeah, I think that's bring some idea to me, and yeah, I just want to think about this, and yes. So, okay. Yeah, so I would just talk in a like high level.
Sure, that's fine.
Yeah, yeah. So I think somehow we can keep track of those unlock, the indexes of those unlock and the indices of those lock.
Mm-hmm.
Yeah, and then we will handle the lock one first. For example, like here, we will handle this, oops, this parenthesis first, and then this parenthesis first.
Okay.
And then to see if those lock one, there's something that could match.
Okay.
Yeah. So basically, we will first work on those lock parentheses, and then we would, I think what I imagine I would do is I would keep track of how many unmatched close parentheses of lock and unmatched open parentheses of lock.
Mm-hmm.
Yeah. And once I record these two, and let me think. Once I record these two, then I can look at those unlock parentheses to see if I can match them.
So when you say you will keep track of how many open or how many locked, open, and closed you have, is that going to be like a number or an array, or in what form will you keep track of that? Like, can you, I guess, do like, if you don't want to code, that's fine. Can you do like a, step by step, like this is what my intermediate results look like for this type of problem?
Yeah. I do want to code, but let me first give you the pseudocode that like for what I would, at least the step I want to do.
Mm-hmm.
Yeah, so let me see. This is interesting. So I would first maybe record all the indices of lock parentheses.
Okay.
Yeah. And then yeah, I can do the unlock later, but like okay, let's first focus on lock parentheses. And then we can just determine all the unmatched open and close parentheses. I would say as their indices.
Okay.
Yeah, so what I imagine would be like unmatched open. Like something like this. ATCH. And then yeah, you would maybe like, let me see if there's a way it doesn't have, yeah, and then unmatched close.
Mm-hmm.
In this case would be like 1 and 3. Yeah.
Okay.
Mm-hmm. And I guess something I'm thinking right now is like, for example, like if all of these are lock,
Mm-hmm.
then like which one is better to match this open?
Yeah. Okay, makes sense.
Yeah. I guess wait a second. I guess I would choose these as close as possible, so that I think use the normal stack trick would automatically do that, so I don't need to worry about this. Like because like
I see. Yeah,
if that
I
makes
get
sense.
it. Yeah. So you're basically saying like if you have a stack of opens, well, yes, I think it makes sense. You're gonna
Yeah.
have like two stacks, but yeah, sure.
Mm-hmm. Like I will automatically match the open parenthesis that closest to the closed parenthesis. And
Mm-hmm.
because the reason why this make me satisfied is because for closed parenthesis, for unmatched closed parenthesis, I want it to be as right as possible,
Yep.
so that I have more chances to match those unlock.
Yep. Okay.
Yeah. Mm-hmm. Okay, so that will be the second step.
Okay.
And
So now you might have basically two stacks of unmatched opens and unmatched closed. So now what?
yeah. So now let's glance things through through all the what is that called? Unlock.
Mhm.
Yeah, unlock parentheses. And let's see. We have some unmatched open, and then so for if we have any indices in the unmatched open, then for each of them, at least we need to find some of the unlock parentheses. Yeah, on the left of the unmatched open.
On the left. Don't they have to be on the
Um,
right?
True. Sorry. Yeah. Oh, that's open. And yeah, open should be on the right. And then for close should be on the left.
Mhm.
Yeah. And
So like in this case, so okay, so they have to be on the right. So let's say I just have some random numbers, like I just have like unmatched open is like 1, 2 or whatever. And then maybe the unlocked is like 0, 3, 5, whatever. So how would you match here? Like yeah.
Mm, yeah, so the unmatched open is 1 and 2, and then I want to match it to unmatched. Okay, unlock, right?
Mhm.
And so as long as those indices is larger than the indices in the unmatched open,
Mhm.
it's a potential match we could choose. But
Right. So there's a
I
bunch. So which one would you choose?
yeah, that's a good question. So and when choosing this, I think we want to choose it smartly, which
Mhm.
is like we will always choose it from the largest.
Mhm.
And the reason for this is we want to leave those smaller indices for the unmatched close.
Mhm.
Yeah, so like we could maximize the chances to match to the unmatched open and match to the unmatched close. If that makes sense.
Yep.
And
So basically you're saying in this case like these two would match with these two and then you'd have these left over for the closed?
yeah, yeah,
Okay.
I think so.
Okay. So you're gonna do this for the open, and then for the closed, you'll just, I guess, get the rest, whatever's left.
Yeah, yeah,
Okay.
and I think there are also some I guess like a sanity check thing.
Mm-hmm.
Like I can immediately calculate if the length of the unmatched open plus the length of unmatched closes, if it is larger than this length of the unlock parentheses,
Sure.
then it's basically false because we're not able to match
I
anything.
mean, I think just like the standard algorithm would just be like you'd run out, but yeah, makes sense. Or you might not have things to the right of whatever or something. Okay. So I get how you do this. I get how you do this. So let's say you have things left over in your unlocked, right? Then what do
Yeah.
you do with that?
Uh, Good question. So, then for the rest of those unlocked parentheses, we need to make sure its number is even.
Mm-hmm.
Yeah, because if it is odd, then it's not going to be like perfectly matched.
Mm-hmm.
Yeah, and then as long as it's even, I think we can always make it match.
Mm-hmm.
Like, yeah, for example, if 6, then I just open, close, open, close, open, close, whatever their indices is. Yeah.
Okay.
And mhm.
Yeah, so I think that makes sense. I think let's stop here. We're at right on time. So got a good idea how you would do this one. So yeah, so let's do the feedback. So what do you think you did well? What do you think you need to improve in?
Yeah, so I definitely need to improve my speed,
Mm-hmm.
like, and also like, I guess I just do sound like a canonical problem, and then I'm not that good at when uh, when I do problem like, how do I say that? Like something never seen before.
Mm-hmm.
Yeah, I definitely need to adapt myself because like when you give me these problems, I have some intuition, but like it's a little bit hard for me to directly translate into something that can really work. Yeah.
Mm-hmm.
Yeah. So I might want to practice that more.
Yep. So I think
Yeah.
there's like two parts usually that are
Mm-hmm.
like core parts of problems is the problem solving part and the coding part, and they're both
Sure.
like pretty important. So I would
Yeah.
say for the first one, you understood like what to do because it's like pretty like everyone knows how, like what to do in this problem, right? But it's like it's very simple, but at the same time, there's like a lot to do, and like how do I write it well, and then how do I
Yeah.
know where I'm going, and like all this stuff, right? So I
Mm.
would work on, and this is this is pretty typical of a lot of PhD new grads. Is like you do a lot of
Oh.
like research and
Yeah.
stuff like that, but you don't do a lot of coding, a lot.
Yeah.
So
Yeah.
I have a bunch of friends that are like that. That are like well, not a bunch, but a decent amount. Where like you study some like theory and you do a lot of experiments, but you don't do a lot of coding. Um,
Yeah. Mm-hmm.
so I would say here, the important thing is you should have. So basically, I wrote that you came up what to do in like a very high level, right? You're like, I'll split it, I'll add the parts, I'll carry it over, and I'll return the sum. But you never
Uh-huh.
really stopped and thought about like, okay, well, how do I actually implement any of this? Um,
Yeah. Yeah. Yeah.
and then during your coding, you were stuck a lot because you were like, okay, so I'm here. So what do I need? So I think I wrote down it didn't plan any parts and stuck a bit in the code because of that. And then you were stuck again figuring out how to add A1 and B1 because you didn't really like plan. You just like
Yeah.
said high level, I'll do this stuff. So I think
Yeah.
it's worth it to take a little bit of time and plan out like how will this actually work. Like so so you want to think a little bit more lower level, like how would this work before coding? And something that
Oh.
would be reasonable is like, okay, well, like some really easy steps, right? So you said like I'm gonna add zeros because I want to make them easy to add. So step one would be like normalize, right? Two numbers. So basically take my A2 and B2 and normalize. And A1 and B1 you can normalize as well, right? So what you could say is or
Mm-hmm.
yeah, go ahead.
No. Just what do you mean by normalize?
Normalized, I mean like maybe it's a bad name, but like let's say I have a number like this and I have a number like
Uh
this. I want
huh.
to add zeros so they're the same, right? So I want to just like do
Oh yeah.
this
Yeah.
because
Yeah.
then it's
Sure.
very easy to add, right?
Yeah. 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 Sure.
So what you can say, and a lot of people don't do this in DSA, but this actually would have helped you. Is you could be like, I'm doing this for both of them. So why don't I write functions that do this, and then that way I don't have to copy my code, and that's gonna make my code better. So maybe I can make a function called like pad, or I guess maybe not normalize, but like pad might be a better, right? So
Mm.
function pad, it takes like A and B, and it does this thing. And you could have called
Mm.
like this and this. You basically have to do this twice, right? So you could have made a function that's like pad two numbers and give you back that thing, right?
Ah, I see.
So you could be like, I have to pad, and then I have to add. So maybe that function could take like A and B and a C in,
Mm-hmm.
and it can return, uh, you know, like total and a C out, right? Because you said you have to use the carry over, right?
Yeah.
So this could
Yeah.
be
Yeah.
another one you could have wrote. Take two numbers, add them, return a carry.
Mm.
And then if you use that, you basically just have to call it twice, and then that's it, right? So it'd be like you call add, with your C in, you get your total, and so this would give you like A2 plus B2 and your C out, and then use your C out as your C in for the next one. So you do like add again for A1, B1, and your C in that you got the last time, and you'd get a
Mm-hmm.
result here again, right? So you'd get like A1 plus a C out. And then basically, if you have a carry, you just throw that to the front because that's like the extra digit. So this would have been
Mm.
a lot more modular, and this would have been like a lot easier to reason about.
Yeah.
Some other things people do to make life easier for themselves is reverse the numbers, and then it's like adding makes a little bit more sense. So you can like reverse and then reverse back. I think that's pretty reasonable because then, but either way, you don't have to do it. But you want to think about like how do I like especially in this part where it's like I'm basically doing everything twice, or maybe you have to do it like imagine you have to do it 5 times. You'd probably figure out I want to write a helper because this just looks ridiculous.
Sure.
But twice it was like still not the best. Like so if you have the same exact code twice, you want to think about like what are the steps I'm doing, and let me quickly write this in this thing. So you could be like, I'm gonna have a pad function, I'm gonna have an add function, and I'm
Mm-hmm.
gonna just like take a few minutes and figure out how all these steps work. And then when you do the code, you just look through it. So yeah, I need a pad function, pretty easy. I just add zeros to make the length the same. I have an add function, pretty easy. It just takes in a B and a C in and this. And then like how does the overall process work here? And this is like 2 more lines. And then when you do the code, you don't really think about, so like how do these things work? Because you already plan this stuff out ahead of time. And the planning might take you like 2 to 3 minutes. Like it's not super complicated. Like I think it's easier to plan stuff without coding than to plan stuff while coding, if that makes sense.
Yeah, that totally makes sense.
So definitely, all right, go ahead.
Oh yeah, sorry. Just like, yeah, writing a function. I have this thought, probably for 3 seconds, but then I was like, am I really going to do it like systematically as a function? And then yeah, I hesitated, and then I
Yeah. A lot of people do that. They're like, am I really gonna write extra functions? I just want to cram it all into one and have it work. Like, come on, it's a DSA problem. Like, why would I split anything?
Sure. Yeah.
Yeah.
Okay. Yeah.
But it definitely helps. So you should recognize like obviously don't make helpers if there's no point, but if it helps, then do it, especially if you're doing the same thing multiple times, and you should recognize that. Like I'm literally doing the same thing multiple times. So a lot of times people will be like you said, I know this is bad, but I just want it to work, you know? And then what happens is maybe you get it to work, but then you have like duplicate code everywhere and it's like not great. And I would argue it would be easier. Like if I did it my way and you did it your way, I'd probably be done first. You know?
I see.
So I know there's this like, I don't want to modularize anything, especially for people who use Python. But if it's good and it helps you and it makes things easier, because you can also focus on each bit. You're like, well, I know what pad looks like. I can easily write it and know it's correct because I can like it's just one little section. And then I know what add looks like and I can easily write it and look and have it be correct and so on. You can also, if you can run your code, you can actually test them, right? So you run them, you write them all, and then you can test them all individually, and then you know it's like working. Where like if you just try stuff and they break somewhere in the middle, like how do you know what broke? So that's what I would recommend is like in the cases where you have a lot of duplication is think about how do I write some helpers. Also, that is like bonus points for interviewing because it's like then you actually have like better code. So people, because the whole like I've seen people literally be like, okay, so I have this, and like I just want to get it to work, so I'm just gonna do this real quick. Like, is that good? We'll just move on, you know. So there's like extreme examples of that, and it's like just literally modularize when it's appropriate. And the big thing is plan. And your coding should be like, I know exactly what this looks like. I'm just writing the code now. And I don't have to stop and think for 10 minutes about how to do every step because I haven't like planned anything.
I see. Okay.
So depending on the difficulty of the problem and depending on how good you are, you can get away with not planning stuff. But I would argue anyone that can just like do this from scratch can also plan and write, and it won't be any slower.
I see.
But people really aren't used to that, especially LeetCode. It's like, am I really gonna pseudocode stuff? Like pseudocoding is silly. And I also thought about that like before I did this stuff, and then I was like, it's actually really good, and it can help you catch your bugs way early. Because what you really don't want is write 20 lines of code and be like, oh crap, this doesn't work. Let me just like delete and start over, because that's like a fail.
Yeah, totally understand.
So the things that helps you is it breaks down your complicated stuff, and you have very high confidence that your coding part will work.
Sure.
Okay.
Yeah, I'll focus on modular thinking.
I mean, obviously, you don't have to go crazy. Like only when it's appropriate, but not. I think the big thing isn't the modular. The big thing is just planning out the hard parts of your problem, and not just saying like very high level stuff. Because if you go too high level and you're not algorithmically very good, you will just get stuck in the code, and this is like super common.
I see. Yeah, that makes sense.
Yeah. Okay, so then let's see. Yeah, so basically for the first one, I gave you like probably like a lean no hire, I guess, because like you didn't have a working solution. You were kind of close though, but yeah, I think your code was not the best because it was duplicate everywhere and it didn't work. And then your problem solving was like this one is more just like, can you break down a problem? You don't need any special algorithms. It's like, do you know how carry works? And that's pretty much it.
I feel like that's like an add to number, and then okay.
But I mean, a lot of people do terribly on this problem, even though it's like you look at it and you're like, this is a joke, and then you start doing it and you're like, man, this is annoying, and this is annoying, and this is annoying, and now there's like 6 annoying things and I'm stuck. So
yeah, this is great. This is a great problem. Yeah, and I totally with this rating, yeah, it means like I need to improve.
Right.
Yeah. These
So,
things.
and then I would say for the second one, so the second one, you basically were like, so I know how to do this problem because I've seen it, but you're giving me this problem and it's not like the one I've seen, so I have no idea how to do this thing because I haven't seen it. So you want to recognize like this one is like, I would assume you basically have never seen, like there is nothing exactly like this one, right? It's like maybe you've seen some parentheses stuff that's like a lot simpler, but this kind of thing, it's like you haven't seen it 10 times.
Yeah,
So this is
no.
another one. This one's more like how good is like your problem solving as opposed to like you're breaking down a problem into steps, I guess. Because
I
this one
see.
is not obvious what you need to do, and this is like the hard
Mhm.
one out of these two.
Mhm.
So
Mhm.
basically, what you needed to recognize, and you did, it just took you a very long time. And I gave you a lot of hints. I was like, okay, so imagine you have like something you can't unlock, and then something you can. How would you do these matches? And then I think you kind of got the idea. But there's a few ways to do it. One of them is like a trick that I don't expect people to come up with, which is like you can basically just greedily match closed with opens, and if you don't have an open, you just match with an unlocked. And if you go left to right and right to left for valid parens, you basically, if you can match all the closed, then you have a valid thing. That one most people don't know, and it's like tricky, and I wouldn't expect people to come up with. I think the one you came up with or something similar is what I would expect people to come up with. So basically, the way I did it was the like more the more intuitive is you have this like unlock one, right? And you store the indices here.
Yeah.
And then you have locked. Or not locked, you have open. And you store the indices. And this is what I was hinting at. So whenever you whenever you come to closed, you basically need to use one of these. If you don't have any one of these, you fail. Right? Like, does that make sense?
Oh.
And this is like more reasonable to come up with because it's not some crazy thing. The left to right, like left to right and back is like very unintuitive, but this one is like a lot more intuitive. It's like you just have to realize like I would rather match with an open instead of an unlocked because it's never better to match with an open because like unlocked can be anything. So I want to save those, right? And you did come up with that. Yeah. So basically the idea is like you first match with an open. If there is no open, you match with an unlocked. And if there's nothing, then you just return false. So now that gets rid of your closed. Now you might have extra opens and you might have extra unlocked. So then yeah, basically for the open, you kind of do what you said, where you need to match like every open needs to have an unlocked after it. So
Yeah.
you basically just like can iterate backwards through the opens and through the unlocked and make sure there's one after that. And then that gets rid of that. And then yeah, like you said, I think the last part is pretty easy. You just like make sure that this is even and then you're good.
Yeah.
So you did come up with it, but it took you a very long time. So this is the other like speed and problem solving ability. And like, you know, if I give you something not on the LeetCode 150, that's pretty hard, which is pretty common for Google stuff from what I've seen. Like their stuff algorithmically is like pretty hard.
Yeah.
So
Makes sense.
and this is like pretty Google-esque, I guess, of a problem where it's like not super easy. You have to understand like there's a bunch of things you can do, but you have to have like one solution that like takes all these concepts and combines it. And it, I guess it's kind of like greedy in a way where it's just like I want to use the thing that I can't modify instead of the one that I can, and then the rest of it is like falls into place, I guess. So it does use the earlier concepts that you know of, like closed parentheses need to get matched, and once you recognize that, like I just need to use the open one first, and then like what needs to happen, then it's like pretty solvable.
Yeah.
But at least you were planning this one, which was good because it wasn't obvious. Like a lot of people will just be like, okay, cool, like you gave me this thing now, okay, so like def whatever, and then they literally like 2% pass rate from there. Like if they don't plan, they're either like a competitive programmer or they've seen the problem before. For this kind of problem, and there's like no way in hell they're gonna like basically get it, I would assume. Like I think out of everyone that didn't write anything that just went into code, it's like a 5% pass rate. So
Oh, okay.
yeah.
Sure.
So
Good to know.
just to give you an extreme, but this is what I mean. That's what I mean. Like I literally just write the problem and they're like cool and they start coding. Like at least for the first one, you did some thinking. But I would just basically recommend do more.
Yeah.
Same kind of thing here for this one. Once you come up with these like steps that you did, then transforming into the code is like pretty easy. So you just want to be very confident that your steps will work. So I would take my steps, walk through the example, be like, yeah, I know this is 100% confident, and now your code works. Because for this type of problem, it's very unlikely you'll come up with the right thing right away if you code. So it's a very high chance if you don't plan anything, you will just code 20 lines and delete it.
I see. Yeah, that's another demonstration. Like planning first is
Yeah.
better. Like
Yes.
not jumping.
But
To
you
the
also have
code.
to have like a certain bar of problem solving ability, right? Like you can't think for like 40 minutes on like how does this work. So those are like the two parts. It's like, can I take a problem and break it down into requirements that are pretty easy to code? It's almost kind of similar to like the using AI now on the job. It's like you just make requirements that are very, very, very good, and then the AI can make code that's pretty good. Except in the interview, you obviously have to code as well, but it's kind of the same thing. It's like take a problem and break it down into very easy steps to code, and then just code the steps.
Mm.
And then
I see. Wow. Okay, that's really. No, I'm still impressed about this question.
Wait, which
Like,
one?
very impressed about this one.
Oh,
Like,
okay.
and I also feel like, yeah, when I do these two questions that you gave to me, like, to me, just like, uh, I would have some feeling, and then
Uh-huh.
certain way. Like, there are just too many possibility. Like,
Right.
I don't. Yeah, I think I need to maybe do more this kind of training to quickly determine which is more efficient or like a solid way to go. Like for example, like for this question, I mentioned like backtracking.
Uh-huh.
Like I don't know, I just have this kind of feeling, but like I also, yeah, I wonder.
Well, I think it's not obvious that like backtracking wouldn't work. Like, I think it should be obvious to you that backtracking will work. If I said do backtracking, the solution's pretty obvious. It's like I just try every state, and then if it gives me
Yeah.
valid, then that's easy. So like,
Mhm.
so you should know that it's valid, and then I can just push on like, let's do something better. And it's not
Mm.
obvious that something better exists. So I agree there. Like, generally the interviewer will tell you to just let's do something better,
I see.
if they're good. If sometimes they just like some interviewers will just be like, yeah, cool, backtracking, then you code it, then you fail. Not much you can do there. You can stop and think if there's a better solution. It's not super obvious, but
Yeah.
usually people, at least the way I like to do stuff, in a way I feel like most people like to do stuff, is if they're gonna fail you for doing backtracking, then they're gonna hint you on not doing backtracking, you know? So,
Sure.
but
Sure.
like the terrible, or I don't know if the terrible interviewer, but like there is an interviewer that will just say nothing and fail you. So
Like how should I avoid this situation? Like, should I, because like I did check like what is the order of the string, but it still might be too slow compared to the.
right. So like the stack thing is like linear. So basically what I would approach this way is like, realistically I'd be like, okay, so like when you ask what the size of the input, I can just be like, I'm not going to tell you, right? So like
Mhm.
preparing for the worst case, I could just be like, yeah, it's not relevant or whatever. It's some size. I don't know.
Mhm.
And a lot of people will do that. Like, this isn't leak code. They're not going to be like, well, it's 10 to the fifth, you know?
Yeah,
So
yeah,
so
yeah.
the best thing you could do, or the like doing your best, is like, okay, I recognize backtracking works, but let
Mhm.
me think if there's something better.
I
And
see.
then if you can't, like, I'd spend like 5 minutes. I mean, it depends on like how much time you have overall. I would think I would spend a little bit of time of thinking something better. And if you can't, I'll be like, I can't think of anything better. So can I do backtracking, or do you want me to improve it? And then usually they'll tell you if they want you to improve it. Because for a lot of solutions, it's not obvious that there's like a linear or whatever. It's
Yeah.
very not obvious. So
I think maybe some of your video mentioned like I should definitely confirm with the interviewer before I start coding, right? Or like,
yeah, you want to confirm, but you don't want to be so there's some people that are like, every step they just ask like, is this right? Is this right? You know? So like, so you want to be like, this is what I think.
mm,
Are we good to go in this direction? You
yeah,
know, like
yeah,
you want to be pretty confident, and then you want to just get approval, and as opposed to just like at every step be like, is this right? And then
sure.
the worst part of that is some people, even while they code, they ask, is this right? I think that's just way too low level. Like, you shouldn't be asking how to write functions and like whatever. I think that's just
Mm-hmm.
not, yeah.
Mm-hmm.
So you want to have like an opinion and get validation, as opposed to try to ask if everything is right.
Makes sense. Yeah. Okay, sure.
Okay. Okay.
Cool.
Anything else?
Like, is there any final suggestion, like, for me? Like, just practice more.
Yeah,
than
so I
just-
would say, yeah, so like I said, I think it's like the same as like chess or anything else. Just do
Mhm.
more problems you haven't done. Like it depends how far you want to get in DSA, right? There's like an infinite amount.
Yeah.
So it
Mhm.
just depends on like where you want to be, and like all of it's like a numbers game. It's like if you're like the best guy ever, you'll never fail. If do you want like an 80%, 90%, whatever.
Mhm.
But basically it's like do things you haven't done, do problems that are like a little bit too hard for you. Make sure you get these steps down. Make sure that it's a totally different interview format for practical than like on LeetCode. You can't rely on test cases, so make sure you do this kind of like approach of like really planning out the parts that are hard, and then you're super confident in your code, and
Mhm.
and then yeah, like you'll get better at recognizing patterns and like problem solving and speed and all that if you just do more. So
Sure. Okay. Thank you for the section today. I
okay,
think I learned a lot. Yeah.
cool. See ya.
Yeah. See you.